5.2, the addition rule and complements. So first, let's go over disjoint events. And disjoint events are simply two events that have no common outcomes. So what does that mean? So if a disjoint event, for example, or two events being disjoint, for example, would be getting heads and getting tails. You can't get heads and get tails, so therefore this event is disjoint. So simply put, disjoint are things that cannot occur in one simple outcome, or basically just things that cannot occur um, in one trial. So if we get a number less than 100 and a number less than 5, and we get 0, 0 is both less than 5 and both less than 100. So therefore, those are not disjoint events. Simply put, a disjoint event is, or two disjoint events are things that cannot occur simultaneously in one trial. And for disjoint events, we can use this formula, which is PE or F equals PE plus PF. And I'll show you on the next slide, which is a diagram. In other words, if you have two events that are disjoint, the probability that one or the other occurs is the sum of the probabilities. And that's pretty simple to understand, but I'll go more into detail on that later as well. So this is also stackable. It's not just 2 points. It could be P plus E plus F plus G. So the probability that an event P, or the probability that event E, F, G, H, or I occurs is the sum of the probabilities mixed together. So here we have two disjoint events. So E over here is the probability that the number is less than 3, and F is the probability that the number is greater than 8. So obviously, you cannot have a number less than 2 and greater than 8. That's not possible. Or greater than 7. So simply put, these are two disjoint events, and then we can apply the probability addition rule for disjoint events. So the reason this works is because as we know, the sum of all probabilities must equal to 1, and therefore let's say that 3 of the 9 outcomes are probability E, and 2 of the 9 outcomes are probability 2 of the 9 outcomes are probability of F occurring. Therefore, if E doesn't occur, there's still a 2 out of 9 chance that F occurs, and simply we can add them together because probabilities are additive. So here's the general addition rule, but this is for P, E, and F. So all that means is it's the probability of E plus the probability of F minus probability of E and F occurring, because it's counted for twice. So here, if we take the probability of E, and we could do this mathematically, so let me do so. Let's take this right here. And I'm actually not sure what this what the thing is here. I'm not sure, but anyways, E, we have the event 57913, and or the sample size, I guess you could say. And then for F, we have 0, 2, 4, 1, 3. So note these two are shared. So if we take the probability of E occurring, we have 5 possible outcomes, and using the classical rule, we have 9 possible outcomes, I believe. Actually, we have 1, 2. We have 10 actually here, simply because we have the 0 term as well. So we have 5, 10 plus 5, 10. But here's an issue, right? If we add these together, we get 1. So that means that the possibility of us getting E and F is 1. That's not possible because we also have 6 and 8 over here, which need to be accounted for. So let's do this algebraically, and let's calculate probabilities that way. So let's denote 5, 7, and 9 as its own thing. So 3 over 10 probability, because this is a disjoint event, plus 2, 10, and then plus 3 over here, 3 over 10, plus 2 over 10. Note that this is accounted for twice. And the issue is that the probability of E and F occurring, or the probability of E or F occurring accounts for this. However, if this is accounted for, then it's also accounted for in the other probability, which is kind of a little bit hard to understand. But simply put, we just have to subtract one of these. And the way we could do so is the probability of E and F occurring, which is just this middle term here. And the probability of E and F occurring here is 2 out of 10. So we just subtract 2 out of 10, cross these out, and it leaves this. So simply put, when measuring probabilities for the general additive rule, we have to cancel out the second term because it's accounted for twice here. Because E also includes this and F also includes this. So if you measure the probability of E and F independently, they both include this term. However, this term includes both, so therefore it shouldn't be counted independently and should be counted within the context of these two data sets. So that's the issue here. So simply put, this is the formula, and here's a contingency table, and basically it measures all the possible or not the possible outcomes. It measures the total amount or total frequency. Therefore, you can make a relative frequency or prototype, whatever you want. So, for example, here, in males in millions, if we add these all up right here, we can calculate how many males in millions there are. And simply put, if we wanted to calculate the percentage of males that are never married, you take the 49.5 million and divide it by the total amount of males to get the probability of males that are never married or that have never married. So let's say we know the probability of an event. How do we determine the probability it doesn't occur? And that's simply easy. It's called the complement. So if something occurs 5 out of 10 times, then it doesn't occur the other 5 out of 10 times. And note that all probabilities add up to 1. So you can simply subtract 1 by the probability it does occur, because all the other outcomes are probabilities that it doesn't occur. And that's what we call the complement. And the complement is just e to the c power. And it's not really e to the c power. It's typically just the e with the c around the exponent area. But that's how it's measured. And this is the up and down union symbols. The up one measures is or, and the bottom one is and. So that's it.